As long as the sun is up, you can walk through this building without turning a light on. We'll use about 10% or less of what a conventionally built home would use. We have this geothermal heating system that's been installed.
It's
high levels of insulation, high levels of air tightness, and advantageous solar exposure. Hopefully creating more power than we're using, an opportunity for intensification. A vegetated trellis where there isn't a glass railing, providing, again, shade for the southern windows. Construction material diversion. A continuous air and vapor barrier all the way around the entire structure. A future rainwater storage space. They're triple glazed, low E, inert gas filled, thermal hinge brakes, there's advanced gaskets, there's fiberglass in the frame. This building was planned, designed, and built to be a more energy efficient building than what is the convention in the Ottawa-Gatineau market. The intention was to create a building that uses many fewer resources than all of the other homes that surround us, specifically energy. And the factor that we were striving for was less than 10% of what a conventional home might use from a power consumption standpoint. And our way of ensuring that we hit that target eventually during the planning, design and development process became the PassivHaus standard. And so this building is now PassivHaus certified, as well as LEED Platinum certified. The PassivHaus standard in particular speaks to the level of energy efficiency that we've achieved here. Really using materials that are off the shelf, using materials that one can find at their local building supply store, and in most cases using local materials, and certainly wherever possible using materials that were supplied, frankly even manufactured here in North America. We learned things about designing to avoid thermal bridging in our exterior walls. By that I mean learn things about designing better walls, better connections between walls and ledges or canopies or balconies, such that, or so that heat can't escape from the inside of the building in the winter time as easily. We've learned things about heating systems, specifically geothermal heating systems in this project that we weren't familiar with before. Although we've used green roofs on buildings in the past, never to the extent at which we find a green roof on this particular building. So there's 16 inches of growing medium above my head right now. Designing a building to support all of that extra weight, designing the roof so that we can contain all of that growing medium, given its depth. That was something new, presented some challenges, and certainly we learned from those experiences. I could probably give you a list of 100 items in this project.
Yeah.
In Ottawa-Gatineau, it's very hard to build a custom home for less than $200 a square foot. $225 a square foot today is a typically used ballpark number or estimation of new home or major renovation construction value. In this project, we spent between $225 and $250 a square foot to build. It really depends on what elements of the building you include within your budgeting. So for example, there's a photovoltaic generating system on the roof of this building. Is that part of the construction value or not? I see that as an add-on. one of those things that take the number from 225 up to 250. But it's an important point of reference. Also the green roof. You know, certainly there's an additional cost to a green roof. Is 16 inches of growing medium typical? Of course, there's a cost associated with that. Is 16 inches of growing medium required on a typical building? Probably not, given most people's goals, most people's priorities. But here we wanted to do it really for reasons of professional development and because we like to garden.